All right, Stephen. So I'm not sure yesterday what the issue was. I think my brain was just really that tired because I had no problem solving this today. So this is the equations, the system of equations that was actually on the part two of the unit test that we were correcting. And so what you need to be able to do with these is not so much substitution as I was calling it. It kind of is like substitution, but they actually call it elimination because we're going to eliminate the y by setting them equal to each other. Now, once we do that, then we just start solving for them. Now, when we have a system of equations like this, one of them is a quadratic and one of them is linear. So that always tells us that we're going to end up with some variation of graphs to where there's options to where you can have either one answer where they intersect, the parabola and the line, okay? You could have 2 points of intersection because it crosses, or you can have, a line going and hanging off and then they never touch. So no solutions, 2 solutions, or 1 solutions. And this is where we use that discriminant to figure out. We don't have to worry about that part today. But now all we need to do is set these equal to each other. It's technically just subtracting one for the other. I just know that I am most successful by setting it up this way and subtracting it one at a time so I do not get confused. What I'm going to do is bring all of my terms to one side. And I wish I would have recorded yesterday so I could see where I went wrong. So then I end up with x squared minus x equals 3x plus 20. Now what I want to do is, whoops, that's canceled out, plus 20, subtract my 20. So now x squared minus x minus 20. And now I need to factor this out. So I know that 4 times 5 would give me 20 and combine to give me 1. Since it has to be a negative, and this needs to be a negative. See, I think yesterday I ended up with one of these being a positive, and that's where I made my mistake. So once I do this, I know that it's going to be x minus 5, so I get the larger is the integer, and then x plus 4. So if I set this equal for the zero property rule, I know that x is equal to 5 and x is equal to negative 4. Now to find the y coordinates that go with those, I'm just going to go back to this first equation, not using the squared one. You could if you wanted to, but that's just a more difficult equation. So it's y equals 3x plus 20 that we're going to substitute it in for. So y equals 3 multiplied by 5 plus 20. Y equals 15 plus 20. Y equals 35. So for our first answer, it is 5, 35. And that's the answer that you had gotten using Desmos. Now on this side, we are going to go ahead and just substitute negative 4 into it. So y equals 3 times negative 4 plus 20. So y equals negative 12 plus 20. Y equals 8. So our second point is going to be negative 4, 8. Those are our 2 answers. So what she wanted to see on that problem is showing the work and the 2 answers. So now here is the problem or the system of equations I want you to solve. So I'm going to put them in the email webmail as well that goes along with this video. And these are the ones that when you get a chance, I want you to work them out. I'm trying to get it to zoom on it. I'm so sorry. Oh, we just had it. I want you to go ahead and solve these ones. It's y equals x squared plus 1 and y equals negative x plus 3. So use that system and tell me what the 2 solutions or what the solutions are to that system. And then that way we can do a test correction. Hope all is well, and I'll see you next week. Take care.